Good evening, welcome to my laboratory. Okay, we have the same setup as in part 2. Please refer to parts 1 and 2 if you're new to what's going on here. The only differences are that I've removed the IRFP 450 power MOSFET, which has a low RDSS, a low drain source resistance when it's on, and I've replaced it with one of Tarbaby's IRFPG 50 MOSFETs on its long leads, and one of them just came out. Sorry. I didn't want to cut the wires, so I just stuffed the socket pins into the connector there. So we have a glare is what we have. Let's see here. There we go. Gate drain source. Did you like that, the way I turned on those little numbers? Okay, yeah. Anyhow, gate drain source of the IRFPG 50 power MOSFET from the Ainsley replication that I call Tarbaby, with its nice long wires on there. Okay, so that's the MOSFET, and I've changed the main supply from no longer using the Allen Co, but now we're using 24 volts, two 12-volt batteries in series with some lead inductance in the interconnecting jumper. Okay, so that's the input to the circuit. The negative of that battery goes to the gate of the MOSFET and the function generator black lead and the scope probe reference. The positive of the battery goes through the load light bulb to the drain of the MOSFET, and then back out the source to this pin right here, which is the positive red wire from the function generator and the scope probe. Okay, so first what I want to do is to convince you that this MOSFET behaves the same as the other MOSFET when we give it the gate drive signal. So here's the gate drive coming up. Did you see that? Did you see that? Where is it? Right there. You see that thickening of that line? Okay, so we got plus 10. Let's put it up to 12 volts there. Plus 12 volts, minus 4 volts, just like before, even though I'm giving it a plus and minus 12 volt signal. And there's the light bulb. It's not as bright as it was before because the MOSFET has more on-state resistance at a 4 volt VGS, which is what we're achieving here. Okay. Okay, so let's see. Can you see the screen and the MOSFET at the same time? Sort of. Okay, so the bulb goes on when the trace is low, just like before. So this MOSFET behaves just like the one I was using before, right? Okay, so now what I'm going to do is raise the frequency of the flashing, okay? So I'm going to just turn up the flash frequency on the function generator, okay? Alright, so we're agreed that the bulb is coming on when this signal is low, right? Because I'm going to go ahead and raise the frequency again, and the bulb will look like it's staying on, okay? But we know that it's actually flashing, right? Let's see here. I'm trying to get a display on the oscilloscopy. Okay, so there's the scope display, minus 4 plus 12. We know that that light is actually not glowing steadily, it's flashing, right? Okay, so now what I'm going to do is move the overhead light a little bit, and let's see if I can I pick this? I have so many wires on this that I'm kind of afraid to pick it up. I'll just leave it right where it is if you don't mind. And what I want to do is show the dependence of the light bulb brightness on a couple of things, okay? Gosh, I really need to have We need to have the bulb up there where you can see it for this, but I don't know if I can or not. Just no. Okay, so what I'm going to do now is I'm going to do this. I'm going to use the amplitude knob to lower the peak gate voltage, okay, like that. That's with the amplitude knob. Okay, so there's 12 volt gate voltage. Now I'm lowering the gate voltage. Now I'm raising it again, lowering it again, raising it again, okay? Got that? So when I lower the voltage, it's an overhead light. So when I raise the voltage to 12 volts, remember this is staying pinned at -4 there. When I raise the voltage to 12 volts, the light goes like that. When I lower the voltage, the light dims. Right? When I raise the amplitude, the light comes back up. When I lower it, the light dims. Right? Right? Got that? That's with the amplitude knob. Now I'm going to do it with the offset knob. Right now there's no offset. When I pull out the offset, nothing changes. Right? So I have the 12 volt gate voltage up there. Now I'm going to lower the amplitude with the offset knob, like this, right? Looks the same on the scope, right? But watch what happens. Lowering, 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 raising, 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 lowering, 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 raising, raising, raising. That's with the offset knob. So I'm going lowering, 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 raising, raising, raising with the offset knob. No offset. Now I'm going to go to the amplitude knob. Lowering, 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 raising, raising, raising. Looks exactly the same, doesn't it? Lowering, 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 raising, raising, raising. Lowering, 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 raising, raising, raising. Okay, so what do you think is going on here? Well, what's going on is that you're driving more and more current through that bottom part there, and if I'm lucky, sometimes with the right frequencies and the right settings, I can even get oscillations. Let's see here. Yeah, see it? See there? Did you see it? You see there? Can you see those? See that? Even though I've got a light bulb in there, which is a nonlinear load, instead of a resistor, I can still get oscillations right in there. You see that? And that's just with a little bit of lead inductance there. Okay. Focus, damn it. See those oscillations down there? See what happens when you turn the offset knob? With sufficient amplitude. All right. Oscillations. Oscillations. Here they are. All right. Thank you for watching.